Bienvenue à Montréal. Pour ceux qui ne sont pas à Montréal, je parle maintenant en majorité, vous êtes ici, très proche. Le- Notre conférencière s'appelle Chloé Clavel, et puis elle est chercheuse senior en équipe Almanach. On n'explique pas ce que c'est que Almanach, mais on sait que c'est l'Institut national français de recherche en sciences de technologie, sciences et technologies du numérique. Ça concerne l'informatique affective et l'intelligence artificielle, le traitement de la parole et du langage naturel, l'apprentissage automatique et la robotique sociale. Bref, tous les thèmes qu'on couvre ici dans cette série de séminaires, vous auriez pu parler sur n'importe quel de ces sujets-là, Chloé. Le traitement des comportements socio-émotionnels tels que le sentiment, l'engagement à la confiance, l'engagement et la confiance. Je suis en train de lire en réel ici. Les interactions humains-humains et les interactions humains-agents, agents conversationnels et robots sociaux. Le titre de la présentation est Modèle computationnel des interactions sociales et émotionnelles à l'ère des LLM et puis de la transparence. Vous avez reçu, Chloé, vous avez reçu les questions et les
Oui,
commentaires des doctorants.
oui,
Donc,
oui,
on a lu ce qu'il y avait à lire. Maintenant, on attend la vérité sortant de votre bouche. Welcome to Montreal virtually to Montreal for this conference by Chloe Clavel on computational models of social emotional interactions in the era of LLMs and the challenges of transparency. I'll be interested to know exactly what transparency means. And with that, I hand it over to Professor Clavel.
Okay, so good morning for you. And thank you, Stephen, for this invitation and for this introduction. So I'm happy to be one of the speakers of this series of webinars. And what I chose to present you today is the research that I've carried out on understanding social interactions. And as you can see in these images, my research explores both human-human interactions and human-agent interactions. And I would like to do this exercise with you on how to put this research into perspective with the latest advances of LLMs, and because these latest models pose challenges for model transparency. And indeed, if they are performant, we have lost a lot of control on how models are actually working when they provide us decisions or when they generate automatically texts. So, in order to explain where I do my research environment, I have just prepared one slide. And indeed, in RIA, as you state, Stephen is a leading French research center for digital science and technology. And the Almanac team is a research team in RIA, and it's doing research in NLP for digital humanities and social computings. And also the research that I will be presenting today has been funded or is actually funded by different projects, European, national, and more local and regional projects. So, but let's first build what we call in the domain of social interactions or common ground, and to try to be sure that we use the same term in the same way and that we understand each other. The research about artificial intelligence and social interaction is not so new, even though people are now speaking about it more and more. So it belongs to the research domain of social and or affective computing. So this domain was born at the end of the 90s with thanks to the book of Rosalind Picard. And the objectives of this research domain are to develop both systems for the automatic analysis of human social interactions, and also to develop more natural human computer interactions by integrating the socio-emotional level in the design of these human computer interactions, and in particular for the development of socio-conversational systems as the natural way for interacting with the computer. So for this research, it's crucial to think about the application and to reflect on why we are building these models and who will use them. Because there is a duality in the use of this research. The same research can be beneficial or detrimental to human beings. For example, if we think about social conversational systems, they can be designed either for supporting well-being and human empowerment or for enabling manipulation. And there is also a debate in our community about engagement strategies in conversational systems, because we were working on how to develop more engaging systems, and early work focused on preventing just users from disengaging during the interaction, especially before the task was completed. So this was a real challenge to keep the user engaged. But now, today, this goal has become more controversial because these systems are now so effective that some companies use engagement strategies the same way social networks do, aiming to keep users interacting for as long as possible, but to encourage the user to come back to the project. And this raises a completely different concern. So this is the risk of addiction and or unhealthy dependence on these technologies. And I would like to mention that a recent article published in Nature takes a closer look at the potential mental health implications of AI companions. In this article, while the results are not black and white, but the study highlights an important issue that deserves more attention in future research. So in order to tackle these societal challenges for my research, I'm privileging applications in education. And first, when modeling social interactions is used for the development of social robots as learning partners. This is what we did through the European project Animatas. And also models for automatically analyzing social skills in order to develop a public speaking training system. So let's imagine that you want to train your speech, and you train first your speech in front of the systems, and the systems give you feedback in order to help you to improve your speech. So this is what we did through this research project. Another application, a second application I'm developing, is applications in health with the study of speech emotion expressions of patients with neurodegenerative disease in order to assist neurologists in their monitoring of the patient, a collaboration with French neurologists and researchers in cognitive science at Hôpital Henri Mondor in France. And so I would like to come back to the challenge mentioned in the title, which is also shared across many research fields, the challenge of transparency. Why are we so many working on this issue? It's because AI systems are now used everywhere, not only by companies, but also by everyday citizens. And this makes transparency a critical requirement, because the way the artificial intelligence systems provide decisions, answer to questions, should be interpretable by everyone. Thus, there is a need for transparent methods that make explicit first the decision-making process behind the automated analysis of socio-emotional behavior in interaction. So how the system is working in order to provide this automatic analysis. And second, the underlying biases of the agent when it interacts with human. And in the context of socio-conversational systems, these socio-emotional behaviors are complex, and we need to be transparent on how they are encoded in the model. So the transparency here is to try to be as transparent as possible on how the behaviors are encoded in the model. But if we look further on the models that are used in affective and social computing from the oldest to the most recent one, so the rule-based approach to the most recent one, the prompting of large generative foundation models, we have seen a significant improvement in performance, but there are two counterparts of this performance. This evolution led to even higher computational resources. The more generic the model, the fewer adjustments you need to make for your task, the bigger it is. And second, this is also at the cost of an even higher opacity. For example, rule-based approach required a high level of expertise in their development, but they have the merit to make explicit the rationales behind the automatic assignment to the class, or behind the way the behavior was generated. But they provide also, they provide a high level of interpretability, but have also a low computational cost. And by contrary, LLMs are very generic. You just need few adjustments with prompting for task adaptation, but they are huge and very opaque. So, and for the social conversational system, we have the same evolution from modular approaches where we better understand why the system is giving this answer or why the system is providing this behavior. And now end-to-end approaches where we have lost a lot in terms of transparency. Now we have a common ground, I hope, about the research domain of affective and social computing I belong, and also the transparency challenges. And so now I will present you the research that we've done in order to make the model more transparent. And my talk will be divided into two research directions. First, describing my research for transparency by design, that is developing computer models that reflects as explicitly as possible the complexity of socio-emotional behaviors. And second, describing our research on dissecting opaque models, that is, when the models are built, developing approaches for studying the model's behavior. Now, let's investigate what we've done so far about the transparency by design. That is the ability of the models to reflect the complexity of socio-emotional behaviors. And in my research, in order to make this complexity explicitly accessible to the machine learning models, we have been working on two levels of transparency. First, the design of annotation schemes that are grounded on social sciences to produce annotated datasets, and second, the design of dedicated model. And you can note that the importance of the transparency by the design from an annotated dataset to model is frequently highlighted by the NLP community, and in particular in, I don't know if you know this paper of Dirk Hovey and Prabhu Moye, and they provide a paper about the 5 sources of bias in natural language processing systems. And in particular, they mention that we have to be, as researchers, mindful of the entire research design. So to be transparent of the data set we choose, the annotation schemes, the labeling procedures, and also the models that we use, and also the way we evaluate the systems. Because it has, so now we will focus on how we will design annotated data sets, because it has an impact on the models that is trained on this data set. So the first level of transparency, the design of annotated data sets. And why it is so important to be transparent at this step? Because the trained model inherently reflects first the content of their training data, which means how in our context, how socio-emotional phenomena are expressed by speakers, by writers in the data. And second, they reflect also annotation choice and the biases used during annotation, which means the way this data was annotated, because the data in its annotation will be used for the supervision and the training for the supervision of the training, of the fine-tuning, of the prompting of the model. But we have to keep in mind that socio-emotional phenomena are complex. Then we have that the data needs to reflect the high variety of socio-emotional expressions. In order to give you an example of such a variety, the study of spontaneous voice shows that emotions are often mixed or hidden in natural interactions. And second, annotations requires high human expertise. And an example that I like to give that it's more difficult to annotate a user's level of trust in their interaction with a robot, for example, than to annotate the presence of a cat in an image. And third, also, so this annotation requires a high human expertise. And also, for such a human annotation tasks, there is therefore human label variation. So the way you will perceive the emotion of another speaker may be different from the way I will perceive the same emotion from the same speaker. So therefore, there is human label variation and then difficulty to define a consensus. So we encode a subjectivity on which we need to be transparent. So let's start with what we did for the first level of transparency, the design of annotated datasets. So in order to ensure the transparency in the creation of annotated datasets, the first crucial step is to properly understand the phenomenon that we want to model, that we want to detect. And to capture its real complexity in data. To do so, we rely on theoretical frameworks grounded in the social science literature. For example, psychology provides materials to define what are emotions, and interactional sociology can be helpful to define trust. So we are going from theories, and we can rely on this literature, to annotated data sets, then make these theories accessible to machine learning models by the design of annotation schemes here, grounded in this literature. And that will provide these annotations for the supervision of the model. So this is a way to be transparent in the design of annotated datasets that are used to supervise the models. For example, in a previous study, we wanted to develop a system that automatically analyzes the user's trust during their interaction with a robot. And when developing the annotation scheme, we relied on this theoretical framework provided by the interactional sociology, and in particular the framework of Goodwin, because it helped us to define trust, the trust phenomenon we want to detect based on this definition. So they define trust as a form of affiliation and credit expressed through observable behavior. This is what is important, observable behavior, whether intentional or not. So the advantage of such a definition is that it focuses on how trust is shown in real interactions and not just reported. which is important for our final goal, because what we want to design is a system able to automatically analyze trust based on the of these observable behaviors. And based on this theoretical framework, the annotation scheme include an identification of a list of social interactional forms of trust and their observable behaviors, such as self-disclosure. We use a similar methodology, so I give another example here, where we go from theory to annotation scheme for a very different objectives, where the detection, which was the detection of stopping point in online discussion. So let's imagine that you have online discussions, and what we wanted to detect is the comments where moments when users pause and resist or question the flow on an online conversation, without necessarily resolving the issue. So this you can have here example of such intervention from the user. For example, when the conversation is about the fake news, or when the conversation is deriving to hateful comments, for example. And here you have example where the conversations were about fake news, and that the user tried to intervene in the discussion, having different forms of critical intervention, such as corrective replies or ironic comments. So here you have kind of example of corrective replies, here on ironic comments. And in this work, the youth theoretical basis comes from three traditions. So reception studies, pragmatic sociology, and conversation analysis. And based on these three theories and an ethnographic study of these Facebook conversations, we built an annotation protocol that include, so it helps us to define an operational definition in the annotation guide, an operational definition of a stopping point, including explicit decision rules for ambiguous cases, such as irony, nested replies, or link-only responses, and also a context-first annotation procedure. So we ask the annotators to first open the shared URL that could be the fake news, read the parent post, examine at least the immediately adjacent terms, so annotating the comments in the context of the conversation in the social network, and then decide whether the comment is a stopping point or not. So because we used all this reception study, pragmatic sociology, and conversational analysis, helped us to define the complete annotation guide in order to guide the annotation of the labelers. And we did it. We did the same methodology for different phenomena, because in my work, when we want to develop a system to detect a new phenomenon, the first step is to provide a data set annotated in this phenomenon. And sometimes such data sets don't exist, and we have to really define what is the phenomena. And we did it for disengagement, H, so here all the phenomena in blue, and for different contexts of interaction, both human agent, human robot, or human agent, and also human-human, such as social media content, doctor-patient interactions, and with different modalities, written, spoken, multimodal, and it lets us to adapt the different methodology and the different theoretical frameworks to these different contexts. So when designing annotated data sets, we also need to be transparent about how we build the consensus, because we can have developed a complete annotation guide, but even with a complete annotation guide, there is certain subjectivity in the way we annotate a socio-emotional phenomena. And it's important to be transparent how we build the consensus when these annotations diverge, if we want to truly reflect the complexity of socio-emotional phenomena in the annotation process. So we cannot ignore label variation and the difficulty to build consensual supervision for our model. But in our research, what did we do? the simplest approach was following research practices and to rely on majority votes for building the consensus. So overall, we try to favor expert annotation. So at least there is a subjectivity, but we can have a subjectivity that comes rather from an expert point of view. And for example, to annotate a data set of patient-neurologist interactions, it was annotated by neurologists in terms of emotions of patients for the study about neurodegenerative disease. But it was not always possible to resort to non-expert annotations. And when it's not possible, we used more annotators for the consensus building. And this is what we did to obtain annotations of persuasiveness in public speaking. So we had a lot of different recordings of public speech, and we asked annotators to annotate the level of persuasiveness with a complete annotation guide. But this was non-expert annotators, so we resorted to more annotators. But what I want to say in the next slide is that this is not what we should do. Because the majority here in the previous studies, we consider the majority vote the right as the gold standard, but we are not sure that this majority vote after when we build the consensus from this different annotation will be the right gold standard. So I want to highlight, because we don't have a lot of choices and it's really difficult problem, but I want to highlight that this problem has been identified by the community, and it was criticized as early as 2020 by the affective community, especially because averaging annotations can be problematic. So in this paper, this questioning of majority vote practices has been raised again more recently in the natural language processing community, with several talks advocating not forcing consensus and considering agreement signal or embracing human variations. But we have still difficulties to know how to do that. But we still identify the purpose. But so we noticed also this issue of human label variation when we addressed the task of annotating fallacies and fallacious arguments in social media, and then try to integrate the annotator's subjectivity. So, but if you are not familiar with fallacy, in this figure you can see an example of a false dilemma fallacy. And we quickly noticed that depending on our cultural background and political affiliations, what is considered a fallacy differs. So we proposed the disjunctive annotation scheme at the span level, so a flexible annotation scheme that allows for several alternative labels for the same spans. And we built some evaluation metrics from this alternative. So far, we don't use this annotation to train the model, but to evaluate the model and to be more flexible in the way we will be annotating, we will be evaluating the model, considering the different perspectives. So we have just examined the first level, the first transparency level, transparency in the data annotation, which critically shapes how models function. But let's now move to the second level, transparency in the design of the model, in model architecture. So this involves designing models that explicitly capture the complexity of socio-emotional phenomena by relying on theoretical framework for the design of the model. And in our research, my colleagues and I have explored different ways to computationally model social science knowledge. First, we started with rule-based. So the obvious way to explicitly model what is of the knowledge from social science. Even though these models are time-consuming and less performant, they provide this very explicit modeling. So we then moved to gain performance to supervised machine learning models with features, supervised models built on multimodal features that are defined from social science knowledge, with the goal to maintain this explicit modeling through the feature design. And more recently, we've worked with knowledge-driven neural architectures, including hybrid models and heterogeneous graph. And finally, we've also integrated this knowledge directly into prompt as a way to align the model to an explicit definition of the socio-emotional behaviors. But this is not a level of transparency, because how the models prompting LLMs, we can try to prompt LLMs to take into account the complexity of socio-emotional phenomena, but how it actually works remains opaque. So now I have chosen to detail you two types of research. There's the work that we did on knowledge-driven multimodal features in supervised machine learning, a work that we did that was presented 2 weeks ago some weeks ago, not 2 weeks, I don't know exactly, at MNLP, and another work that we did on knowledge-driven architectures, a work that we presented a few months ago at NACL. And so let's, the first study illustrates what we did.
Can I ask you, Chloe, we were
Yes.
going to do a pause. Were you going to do it at this late point, or is there already an idea where you want to do a pause for questions? I'm not saying there are questions.
I prefer to have it at the end of the models, but
Models, okay.
but
Fine.
we can still have a pause if you want on the part of the annotated data set. It's a good idea, yes. So we can do a pause now on the part of the annotated data set, questioning about how about this fact about going from theories to annotation scheme. Yes, we can do a pause on that part also. Yeah, okay.
Et vous, je ne sais pas s'il y a des questions, mais vous pouvez poser les questions en français maintenant. Aussi, concernant le haut. Vas-y.
En fait, moi, c'était pas sur les annotations de
C'est
données.
correct. Tout ce qui a été
Dit jusqu'à maintenant.
dit.
Bonjour Chloé, merci d'être là avec nous aujourd'hui. Au niveau des annotations, je serais curieuse de savoir, après vos recherches, quelles sont les limites que vous avez constatées qui pourraient donner lieu à d'autres recherches, parce que on voit que c'est structuré puis systématique là, en fait comme modèle d'annotation que vous avez utilisé, mais jusqu'à quel point c'est généralisable pour annoter tout ce que vous avez besoin de.
Oui, je te conseille de répondre en anglais, mais répéter un petit peu.
Okay. Yeah, the question was about the generalizability of the annotation schemes that we developed. That's true that the annotation schemes that we developed are developed for a certain domain and for a certain because the set of emotion or socio-emotional phenomena that we will consider will vary from one application to another. But when we consider, for example, the work on trust in human-robot interaction, the idea is to build a framework that works in the context of human-robot interaction, and that could be generalized to all human-robot interaction. For the stopping points, when we want to detect an annotation scheme about stopping points, the idea was to be able to generalize in all the social network platform, even though the comments from YouTube and or in forums. But that's true also that we have this purpose, but we don't test we haven't the opportunity. I think it's not because it's really costly to develop an annotation scheme on this. So we try to think the annotation scheme in a general way, but and to define exactly what context it applies.
Okay, there's another question now from Paul.
Yes, this will be in English, but again, about the stopping point.
Yeah.
You mentioned that you look at the context, and the stopping point is most clearly signaled by what happens after it.
Yes, yes.
Yeah.
Yeah, it's a good question because yes, the context is also the surrounding terms. What I say here is the surrounding terms is also what happens after. So we give the annotators this information, but that's true that if we imagine a system that try to detect it online, because the way also we annotate, we use a theoretical framework, but we think also about the design of the system. But for us, it's not a problem that the system also look at the whole conversation before taking its decision. But it's a good question because it's not looking at the previous context, but looking also at the next turns that will also maybe give information about if these interventions was successful or not.
Yeah, thank you. Thank you.
Very good. Okay, I think you can proceed now.
Okay, so we were speaking about the annotating scheme, and now the idea is to see how we can ground the way we are designing the models, the computational models in the social science. And I will start with how we designed multimodal features for repair detection. So the work that we did in order to make this formalization of repair as defined in linguistic theories accessible to machine learning models, but through feature design. So we used an existing data sets where they already have done this work on grounding their work on repair on the conversation analysis theories. And the idea is to see how we can design a model that takes into account also what social science literature knows about what is a repair. But first, let me explain what is a repair. You can see an example of repair, and more specifically in this study, we are interested in the development of a system for the automatic detection of other initiated repair. So the repair sequence is here, and we want to detect when one speaker initiates a repair. And the conversational analysis literature provides meaningful descriptions of repair phenomena and their expressions. And this is what we want to use, is what are the multimodal cues that are identified as repair initiation in the literature. And we relied on this literature in order to provide a library of acoustic and prosodic features that are included in a more involved architecture that you can see here. Here you have the repair sequence, and we want to detect here this sequence about repair initiation. And so we have as an input the linguistic the text, the sequence in the conversations, and we encoded it in a way where we keep the conversational context construction, and we extract from this sequence some features that we combined, the linguistic and prosodic features that we combined with the text and audio embeddings using a cross-attention fusion layer. And in the end, given an input that is a speaker utterance, the classifier determines whether it is a repair initiation or not. So an example of this knowledge, linguistic and prosodic features that we derive from the literature is, for example, the speech slope transitions coming from literature on prosodic entrainment, or other repetition and self-repetition ratio coming from literature on conversation analysis. But what about obtain results. We wanted to study what was the best approach, using the embeddings only, using the knowledge-driven features, or combining both through the cross attention layers. So what we need to know is that the data we were using were for testing our model is CAPS corpus, corpus in Dutch, annotated in Reaper. Yes, that was not developed by us. It contains dyadic interactions, and where two humans are collaborating in order to on an object matching task. So you can see here the obtained results for each modality. And so here the results obtained for each modality, and combining the two modalities using embeddings only, or so here you can see when you use multimodal features, and here when we use embeddings, and when we use linguistic and prosodic features, and our models combining all. So what are the key takeaways? First, for both settings, multimodal models perform better than unimodal. You can see here that we always have better results here than here when with monomodal models. And which means that audio and text complement each other and leads to better performance. Second, using design linguistic and prosodic features. So yes, embeddings give good results, but linguistic and prosodic features alone without using embeddings gives also similar results. And they are more explainable to use these linguistic and prosodic features such as pitch slot transition or auto repetition ratio, and give similar results to the embedding. So it was a nice results for us. And also that there are significant improvement if you combine both linguistic and prosodic features designed from knowledge from social science, and audio and text embeddings. And so this knowledge-driven feature complements the pre-trained embeddings in the multimodal settings, and we have a significant improvement with our architectures. So another example, because in the previous study we intervened at the level of feature design and the use of cross attention layer to integrate the features in a smart way. The second study I chose to present you is the work we did in order to intervene at the level of the neural architectures to reflect the complexity. And we developed a model that we called hemodynamics model, which is based on graph neural network. The model investigates the modeling of the conversational dynamics within graph neural networks for the task of next strategy prediction. So first, let me explain the task. In this task, the input consists of a sequence of speaker turns, and after an utterance from the user, the system has to decide which socio-emotional strategy to use to answer to the user. And the system has to decide, so among various emotional strategies that you can see here, for example, affirmation and reassurance, providing suggestions, restatement and paraphrasing. And for those who are familiar with dialogue systems, this task of next strategies prediction corresponds to the dialogue policy module in the modular dialogue systems. Here is an overview of our proposed prediction framework. This is a classification task. So we want to predict the next strategy given the dialogue history. So it is based on graph. So we have here the dialogue history, and here the output, which would be what is the best strategy to adopt in the next term. It is based on graph neural network for a modeling of this conversational dynamics in the dialogue history. And I will now detail on all this work. Firstly, we used an off-the-shelf discourse passer to identify the relationships between utterances. For example, that an utterance is an elaboration or a correction of another one. Second, we use an off-the-shelf emotion recognition model in order to understand the emotional content of the past utterances of the user. So the idea is to make the model use this information about this emotional content expressed in the utterance of the user in the dialogue history. And we choose to represent this emotional content by emotion distributions rather than emotion categories in order to capture mixed emotions. And the mixed user emotion embeddings are obtained then by multiplying the emotion distributions with a learnable emotion code book in order to obtain the mixed user emotion embedding, so representation of the emotion of the user in the dialogue history. And then all this information, the mixed user emotion, the agent strategies, and the discourse dependencies is integrated using an heterogeneous graph with nodes that integrates, here you can see the nodes, that integrates embeddings of the agent strategies in the dialogue history, the mixed user, the embeddings of the mixed user emotion embeddings provided by the emotion recognition module, and then the edge here that encode in green, the discourse dependencies. In yellow, the interspeaker connections. And in dotted yellow, the self-speaker connections. And we use, so we encode here all this conversational dynamics and the discourse parsing and the emotional and the emotion. And we use relational graph attention network and a dummy node in order for information aggregation. So the idea is to make it in a way, in a compressed way that could be understandable after by the neural network. And these dummy nodes have this global representation of this conversational dynamics of the dialogue history. And the question is now, how does such an approach perform? We compared the models to 3 types of baseline. So first, the state-of-the-art baseline. So here is our model in red. And here is the state-of-the-art baseline, trans-ISC, which is a common sense knowledge graph, which was the best baseline for this task. We also fine-tune here a state-of-the-art large language models. And here we also test just with the prompting of a state-of-the-art large language model. And what we showed is that we were happy because our model gives outperforms all baseline across all metrics for this task. And we were happy also to see that just prompting an LLM did not allow to solve this task of next strategy prediction. So we use a similar approach, but for modeling the conversational dynamics of into graph neural network, but to model the conversational dynamics in social networks such as Reddit conversations, and for the detection of abusive language. And so if you are more interested to this task, you can have a look on this paper that was presented in July in ACL. And now I will present you the takeaway so far, and we will have also make a split in order to, if you have questions. So the takeaway so far is that interdisciplinarity is crucial for transparency by design. And this call for interdisciplinarity was also echoed in this talk of Verena Reiser and Dorkovi at ACL, because they say that we need to communicate with other disciplines to understand human nature and social context better. And this is what we are doing in our research. because we relied on the social sciences to design our annotation process, and it helped us to better understand and model the phenomenon we want to detect, and also the subjectivity of the perception process. And also, it allows us to better design or to build new neural architectures that better reflect in a more efficient way the interaction process. And I'm convinced that it is important to be able to have this implicit encoding of this information, because this leads to models that are more transparent. So before moving to the next part, I can take also other questions.
Merci Chloé, super fascinant. Pour ce qui est de l'Emotion Codebook que vous aviez dans votre graphique, la représentativité des émotions à travers les cultures, est-ce que c'est un enjeu qui a été pris en compte?
It's not, so the question is about the cultural
Motion
aspect.
code. Je sais comment ils sont codés.
Yes. Yeah. So it's really important question and issue that you raise here, because the way we are modeling emotions is the way they are illustrated in the data set. And that we are considering. And for this study, I didn't mention, I was not transparent, you're right, on the data set that we were using to build this model. So we used existing data set. Okay. We used existing data sets in order to do this task of emotional support, and the existing data set were English, maybe American. So there were data set for emotional support that corresponds to crowdsourced data set, where they were asking people to interact together on different topic, and to take the role of emotional support, and to observe all how humans are doing this emotional support naturally. But this has been done in English, and I think in crowdsourcing platform, and I don't know where the crowdsourcer were coming from, but what we are encoding in the way they considered that they are expressing emotions in the way from their own culture, and we are modeling that what is in the data. So this is really important to highlight this. And about also the categories of emotions that are considered here, we choose to use this combination of emotions from the, because in a lot of data sets, emotions are annotated in these big 6 categories that is really criticized by the affective computing communities. So that's also why we use rather mixed emotion, and to use rather emotion distributions to tackle this issue, because we were also depending from the data set. So that's true also, that when I'm doing research on data set, I'm applying some guidelines in order to integrate different emotions categories, and also to explain what is the language, it was Dutch or it was English that's present in the data, what are the cultures that are present in the data. But when I'm working on the models, we are using existing data sets, and what the only things that we can do is to highlight in the limitations that there could be a bias, and there is a bias in the models that we have built. It's a bias coming from the data sets.
Thank you.
Excellent.
So if there are...
Go ahead.
Yes, I can. Is there no other question? I can. Okay, I can go ahead and go to the next part of my talk, because we've discussed the 2 levels of transparency by design, making models transparent by explicitly encoding social science knowledge through annotated dataset and dedicated architectures. But now we'll explore different directions. So how can we dissect encoded in machine learning model. That is what models have learned, and not that the most opaque models, the most performant typically, are also the most challenging to interpret. So this question concerns many researchers, albeit in different contexts. So the scientific community's efforts in machine learning and computer science to develop more interpretable artificial intelligence model is huge. And current research can be broadly categorized into two types of work: analyzing what behaviors matter in the prediction generation process, or analyzing the inner structure of the model, such as through mechanistic interpretability. And my research is so far from the first type. We have applied existing methods like SHAP analysis to identify features that drive predictions, and we have also developed novel post-hoc explainability approaches with the dissection of attention mechanisms in neural architectures to better understand this decision-making process. And this is this part that I will present you now with more details. It is also important, before I go through this study, to note that model interpretability serves different audiences. This may include non-expert users, for example, citizens using ChatGPT, or specialists such as practitioners or AI developers and researchers. And depending on the audience, the method that you will develop will have different objectives or will be different. And in this landscape of dissecting approaches, interpretability, my current research addresses interpretability for multiple audiences, practitioners, like coaches in public speaking training systems. So are they able to understand the explanation coming from the machine learning models? Recruiters to better understand the decision process. Neurologists who need to understand decision-making processes, as well as also AI developers and researchers. And here I want to share with you an example of post-hoc explainability approaches dedicated to the dissection of supervised neural models. So our purpose was here to understand recruiters' subjectivity in job interview assessment. And to do so, we have dissected the models trained on recruiters' supervision. And we proceeded in 3 steps. First, we built this model. The models that we trained on recruiter supervision. So we have the model is based on attention mechanisms at different levels. So within the multimodal candidate answer and at the global level of the interview. And second, so we build these models to predict from a multimodal interview, job interview, the decision of the recruiter. And then we dissected the model by analyzing the attention mechanisms at different levels. So within the multimodal candidate answer, or at the global level of the interviews. And so the idea for the attention of this attention slices, is so by analyzing the attention mechanisms, we want to retrieve what we call attention slices, that are these salient moments in the assessment of job interview. So we want to look at on which part of the interviews the neural network is taking attention through these attention mechanisms, and then study what are in this attention slice in terms of social cues. And finally, we analyze this timing and the content of attention slices that are in terms of this multimodal social cue. And 2 main results emerge from this analysis. Attention slice tend to occur at the beginning and at the end of each answer of the interviewee. And attention slices contain more breathing, fillers, activation of some action units, such as the ones that you can see here on the video, and also specific vocabulary linked to competencies. So to note that even so we did not carry out a proper evaluation, we identified some common findings, what has been identified in human resource literature. And these types of methods in the landscape of approaches for explainability are named post-hoc explainability methods because they dissect the models a posteriori. So what were the lessons learned from this study on attention mechanisms? Well, we did similar study, which is just a step towards explainability. In these two papers where we also relied on attention mechanisms to better understand the model's predictions. Therefore, we can try to dissect a model. It gives some information to try to understand the decision, but this is very local and we cannot completely retrace the decision process. So we need to, such as it could be done when we were using reasoning models or rule-based approach. So we need to develop approaches to better understand the level of interpretation the approaches provide. And so we can do, no, I will finish here and we will have the question in the end, I think, so that I'm sure to present all, and I'm sure also to not to spend to save time for questions. So you may have noticed that you have now the possibility to prompt LLMs to obtain annotation and explanations of their annotation. So the question that we have now is, what about prompting LLMs to provide annotation of trust, of stopping points, and to study how reliable they can be. As LLMs are very opaque, yes, the question is how reliable can be these evaluations and explanations. This is a question that we investigate for the task of evaluating a story. We developed a meta-evaluation framework. And the idea was to study human here versus LLM annotation. And we defined different multiple criteria for story evaluation, narrative coherence, surprise in ending, the story's capacity to engage the reader, and so on. And here is an example of rating that we use for the criterion, the story's capacity to engage the reader. So here you can see here what answers the LLM. So we ask the LLM to provide also an explanation of its rating, and we then conduct a user study on this explanation. And we ask in this user study, we ask the human readers to read the story and the LLM scoring and its explanation, and to tag potential issues, and in particular to tag unsubstantiated claims. So the meta-evaluation framework and the user study led to mixed results. We showed that the meta-evaluation showed that LLM cannot be relied upon to evaluate a single story, but are the best proxy compared to non-LLM automatic measures. Second, LLMs appear to be more reliable for comparing different models and dissecting and selecting the best one. And here it was Beluga. Third, LLMs understand the evaluation task only partially they struggle to explain their answers with substantiated claims because 31% of the provided explanations were annotated as unsubstantiated claims. So this results that begs the questions of whether the model, here it was Beluga, truly understands the given task. And this means that we did not when we did the study, we were not able to ensure the reliability of the LLM evaluation as well as the LLM's explanations. So we used a similar approach to evaluate LLM's ability, but this time to evaluate persuasiveness in public speaking. So we define criteria of persuasiveness and test the LLM's ability and compare it with the human annotation of persuasiveness. And for more details, you can refer on this paper. So let's try to conclude together. What are my key messages? So as mentioned before, interdisciplinarity is a key lever for transparency. It allows us to explicitly model social science theories, both in the annotated dataset used for the training of the models and in the computational models themselves. And this call and the second message is that we have seen how alternatives to LLMs can be developed to explicitly model knowledge from social science, in particular heterogeneous graph with relational structure, prove to be more transparent in explicitly modeling social science theory, and also hybrid models with knowledge-driven feature for the detection of repair. So they sometimes give better results than LLMs while being more lightweight and offering better transparency, or at least allowing a better view of how they work. We faced also difficulties analyzing and understanding how prompt-based approaches actually function and how much reliable they can be. And I believe that I believe that these heterogeneous graphs, these knowledge-driven multimodal features are viable alternatives to LLMs in terms of approach because they are lighter and more understandable, and we should continue pursuing research in this direction. And the third, the effort to dissect models also must continue, so we can still consider the LLMs and opaque model and try to develop methods also to better understand how they work. So we've explored how attention mechanisms used in neural architectures, not in LLM, but in neural architectures, can provide us local interpretations. But we are also now working on two fronts, studying the usefulness of the explanations, depending on the audience, through user studies, and explore other approaches to better control models, particularly in generation tasks. So last but not least, the work presented here is carried out with my collaborators that you can see here in these pictures. And so now I can also answer your question about the last part, but also about the first part of my talk.
Thank you very much. First, let me thank you for giving that very interesting talk, and even before the questions, for coming here and doing this for us. I'll launch the questions just because we're usually sluggish. Not you.
Non, mais j'en ai d'autres, mais je ne vais pas abuser.
No, good. But I do have a small or a big question. What do you mean unsubstantiated? I'll give you three choices.
Yeah. Unsubstantiated is that if the explanation explicitly refer to the story in order to explain its rating to the story and to the criteria. So we can have a look on here. This is an example. I found the story to be confusing and difficult to follow. Is a little bit vague, and there is not substantiation and exactly where in the story it was difficult to follow. But in here, the plot seemed to jump around without providing clear context and enough information to understand what was happening. It's substantiated, but the user who has to annotate it, the substantiation, has also the story. So it can, the user, the human can, the annotator, sorry, can also look at whether indeed this corresponds to actual. This corresponds to the story, indeed to what happens in the story. So the guidelines for substantiation is a little bit difficult to define. So we also did this about substantiation. We defined substantiation for review. So in another work, we annotate reviews of papers and the substantiation in terms of reviews of paper. And this is based on an argument mining framework where you have to have the claim and then to really explain the link between your claim and the different arguments that you have in your review.
It's not a completely transparent criterion. I mean, I can interpret it as saying it's substantiated if you have produced something in the object that's being evaluated as evidence.
Yes, exactly. It should be substantiated in the object that you have evaluated.
There's more. That's you just cite something. Number two, is it in fact supportive, or is it? And is it substantiated if you find contradictory evidence?
Yeah. We could formalize it in a more logical way. We didn't do that, but it could be a good idea to better define it in a way where we are looking if there are also problems in terms of reasoning in the way the argument is explained. And because we tried to do that for fallacy detection, to detect some, so to model the logic of an argument and to try to detect where there is where the link between the different arguments are broken or are not logical. And this could be done, yes, in a more, I agree, in a more structured and more documented way. Here, as it was provided by LLMs, the idea is the LLMs completely inventing the things or not?
And there are precedents for this. I mean, we talk sometimes in empiricism of positive evidence, negative evidence, and absence of that evidence.
Okay. Okay. Yes, if you have the reference, I will be happy.
It's all over the map because of that standard empiricism. But yeah, I can send you something.
Yes.
Now, go ahead. Say your name, by the way.
OK. Ben oui, Chloé Sherazade. Une autre question pour vous concernant, en fait, je pense que du peu que je connais de ce domaine, vous êtes avant-gardiste un petit peu dans la perspective de vouloir structurer un module transparent pour les émotions, même si aujourd'hui, il n'y a pas de consensus sur tout ce qui est émotionnel et tout ça. Plusieurs choses. Un, est-ce que vous êtes référé à une théorie de l'esprit quelconque? Si oui, ben laquelle? Ça, c'était ma question la plus générale.
The question about the integration of the theory of mind in my research, so I didn't do that. I haven't do that so far. But there are a lot of papers that are starting to test if LLMs are able to have this kind of theory of mind. I've seen some work about that, but I have not integrated it in my research so far.
Et vous trouveriez que ça serait pertinent?
Yes. And I think that other people have done that.
Oui.
Yeah.
Et dans ce sens, justement, on a eu un séminaire la semaine passée sur les Global Workspace,
Mhm.
une manière d'avoir des hubs un peu plus structurés qui auraient la capacité d'intégrer des modules éventuels pour tout ce qui est
Mhm.
contexte, tout ce qui est émotion. Alors, je me disais, je connais rien au monde des émotions en niveau science, mais c'est très relié au contexte. Est-ce qu'au lieu juste d'annoter le contexte, il serait pertinent de faire des recherches sur créer des modules, de structurer des contextes de toutes sortes, au lieu de juste annoter des contextes à partir de données qui sont pratiquement occidentales et probablement biaisées.
So this is a question about context, but I'm not sure to understand what you mean by context here. Is the conversational context or the context of, for example, the personality of the speaker, or it's all of sort of contexts?
On pourrait, en fait, toutes ces réponses, il faudra le définir, mais c'est plus la notion de, est-ce qu'il serait intéressant d'utiliser la notion de global workspace pour une transparence et une modularité supérieure encore dans des recherches comme les vôtres?
So I'm completely agnostic about the global workspace. So I don't know what is it. So I could not answer. But it seems to be great in the name, global workspace, in order to be able to articulate the context. What I did so far from my side to module the context is to use graphs, but I don't know how global workspace are working.
Ben, en fait, moi aussi, j'ai appris ça la semaine passée. Tout ce qui est Global Workspace, c'est une manière de structurer d'une manière plus transparente une certaine version de la théorie de l'esprit, d'avoir un hub central où ben, il y a une gestion de données puis des modules autour qu'on pourrait implémenter, toutes sortes de modules. C'était un scientifique de Bordeaux d'ailleurs, Van Roolen, si vous voulez vous référer, peut-être plus en détail que ce que je pourrais expliquer. C'est Ralph Ruffen van Rulen,
Il est
Ruffin, voilà. Donc de Bordeaux dans des instituts de sciences cognitives. Donc,
Ah,
super intéressant ce qu'il a présenté, mais je voyais peut-être une extension.
mhm.
Je vais
Yes,
chercher.
yes, I will have a look, and it's really interesting because also when I'm not coming from cognitive science, so I'm working on natural language processing and machine learning, and when people who are working on this rather theory of mind and are rather from cognitive science, it start to come in natural language processing to look at theory of mind, and yes. But this is a good thing about interdisciplinarity. So I will have a look.
Thank you.
Yeah, go ahead. Wait a second.
It will be in English, okay?
Yes, do it in English and say your name.
My name is Yasmin. Thank you for the presentation. Really hits the point that I already worked on prompting using LLMs to do automatic annotations. So
Okay.
I have published a paper for a couple of days in a conference that concerns social network analysis. So my experiment was about do automatic annotation by giving a large language model the context and do the labeling automatically, but without just writing or injecting the model with the prompt. I inject the model with the context by adopting theory in the social sciences. What
Okay.
I obtained a well results, not bad results. The
Okay.
accuracy was above 80%, but I do a small another evaluation experiment by human.
Mm-hmm.
It was very, very small experiment. The annotators was master students. So I conclude at the end the same conclusion that you present today, that I have to expand more people to do the evaluation. And also I should include interdisciplinarity annotators, human annotators, because the one who annotate or validate what I got is just from computer science domain. So once we talk about social sciences, I think, yeah, we need, I totally agree with your conclusion.
Yeah, it's to
Thanks
have
for
more.
confirming what I got, because this is the way that we need to to conclude the same things that will push us forward to work on another aspects. So now we can say that including human experts in multidisciplinary domains is very important. So thank you
Yes.
for.
Yes, so I agree with you, and yes, it's really important to compare with human expert annotations. And also, what I would like to mention also, because in the stopping point, for example, which is a concept which is not well known by the LLMs, even though we try to define really precisely the concept in the prompt, the LLMs did not understand well what are stopping points, but when we try to train the model on the supervision of labels given by experts, the model was better. So with the model supervised by expert was better than prompting an LLM with trying to provide all the expertise of the concept.
I have a small question regarding the prompting point. Your experiment about prompting, did you use the graphical user interface or did you use the API? Knowledge? Because there is a big difference between both. Once you use the graphical user interface, it will give you different results from using the API. With the API, you have control parameters that you can adjust to gain more little bit accurate results than the GUI.
No,
So,
use the API.
Yeah, because the API, it gives different results from my own small experience.
Okay, yeah, interesting.
Thank you.
Are there any remote or local questions? I've lost I will have to look at the remote to see if there's a hand up, because I've reached the.
Yeah, Stephen, I had a quick question.
Yes, in fact, before you ask it, I'm going to make a guess. Are you going to ask her about what she thinks of Pavlik's work?
You mean Ellie?
Yes.
No.
Okay.
Well, that was a very interesting talk, and it made me think about a couple aspects of emotional response, in particular to LLMs. Now, but a lot of your discussion was about annotation. Of course, LLMs as transformers have no annotated samples whatsoever. You could have arguably, you could have a path dependence where you choose samples. Let's say you're trying to do some medical application, and maybe you start out with livers and pancreases and things like this, and then you move on to ears, eyes, nose, throat thing. So the problem is there's going to be some sequential bias in these LLMs in terms of the way they learn things. But since we don't know how they learn things, that's very hard for us to understand. But here's the thing. It's very clear that when people have adopted an LLM, their favorite chatbot, I'll take Stephen as an example, there's a lot of emotional responses to the chatbot itself. And it appears recently from Anthropic that they have now given an option for Claude, which is their main LLM product, to ghost people who are abusing them. So in other words, if they feel like they're being treated like a graduate student that is being abused by their advisor, which does happen, they will just say, sorry, I'm done with you, and leave the conversation and ghost them forever. Now, that does raise the eerie question. Do LLMs have emotions? And why do they have this response to abusive characters?
So LLMs have no emotions. They are trying to reproduce what they imitate.
Well, how do you know? Oh, no, they're not trained to reproduce anything that they imitate. That's just false. They
Because
actually
the way they're built,
predicting a word. I know
yes,
how They were predicting the next item. So there's no sort of imitation in here. They're not a mirror system in any sense, if there was one. So I'm not sure that, but when you say they have no emotions, how do you know that?
I know that the way they are trained is the method
I'm
that
aware
I
of
use.
the way they're trained, but that doesn't give you any kind of argument for whether they have any emotion or consciousness or anything. I mean, the people who interact with them certainly have emotions and beliefs about the way they're behaving, surely. So you're simply saying that's just a mirror.
Yes, they have observed a lot of behavior from humans, and they try to reproduce it, and they have seen occurrences where humans are doing things like that, expressing their emotions, so they do that.
Well, so that would make them very mechanical and robotic then, right? Because it would just be very much like an old rule-based or GoFi system that would be like Eliza, or it would simply repeat what you just said. And if you were emotional, it might say, "Why are you so emotional today? I don't understand." But that's not what they're doing. It feels like a human interaction. It feels like you're talking to them. And you could say, well, that's just the human response. But clearly, if they can signal to Anthropic developers that they're unhappy with their chats, there's something else going on here.
Yeah, the debate is open, I think, for this question.
Well, yeah, sure. Since we have no idea how they work, these speculations become nothing more than just, kind of arm waving. There's no real,
Steve,
question.
somebody could also, instead of speculating, they could make a hypothesis. I think you agree that when your Claude wants to kiss you, and when you made such a good point,
And it's sycophantic.
Yes, when it's sycophanting, you're not calling that an emotion, because you know, as I know, that they've been overtrained on that as a good consumer strategy.
Oh, I checked into that, Stephen. I actually checked into that with Anthropic, and also OpenAI does this. They build wrappers around these things, and there's an enormous amount of anger and abuse coming from an LLM if you don't do that. Okay, they do not suffer humans very well. There's no question to that. So,
can't we say?
Hi, Paul. How are you?
Hi, Steve. Love your beard. Can't we say that Anthropic has done a kind of stopping point analysis, and it's identified a kind of behavior, which is exactly the kind that Chloe is talking about?
Well, their argument internally, if you talk to the people there, they say they have sensors, meaning they have some kind of metric sitting inside of Claude, and Claude gets, internally quite upset. It basically doesn't like being called names. It doesn't like being called stupid, which a lot of users do. Oh, you got it wrong again. You're such an idiot, stuff like this. And it simply says, I can't take this anymore, and it stops it.
Ask Claude people whether in fact they have not done something. I think they have. I think
they do have these wrappers, Stephen, and the wrappers are meant to make them polite. And as you well know, you spend a lot of time saying please and thank you to these things. So and they do seem to respond to this, but it does tend to reward more sycophantic kind of behavior coming from the LLM. I agree with that. And so at some point you have to say, you could just say yes or no. You don't have to tell me what a wonderful person I am and how smart I am.
But that might offend the Claude.
It might, and so there's a fine line there, because you could get to a point where it feels its feelings are hurt, whatever that may mean.
Chloe on that. They aren't there. It's anything but that. But
well, yeah, you and I heartily disagree.
Yes. Okay. Unfortunately, we have now reached the end of our time. I really enjoyed this last part. It always becomes, oh, wait a second. There's one more French question. mais rapidement.
Ouais, rapidement. Bonjour Chloé. Merci pour votre talk. C'est pour revenir à la question de la notation aussi. On a eu un talk la semaine passée sur le symbolic knowledge distillation. Je ne sais pas
Mhm.
si vous êtes familier avec ça. Donc, je me demandais si ça pourrait être pertinent dans votre approche, si vous voyez, si vous voyez le concept dont je parle, pour
Euh,
l'émotion notamment, des choses comme ça.
Disons que I have not seen the talk, but correct me if I don't understand. So the idea is to see how we can distill knowledge coming from a symbolic data set or knowledge bases in order to better control the LLM.
Non, justement, c'est à partir d'un LLM.
Mhm.
Il filtrait justement, ça requiert peu d'humains, mais ça requiert des experts.
Mhm.
Et, voilà, j'ai l'article sous les yeux, je suis pas sûr de, de le comprendre dans les détails,
D'accord.
mais je pourrais peut-être vous envoyer là, enfin, vous
Ah oui, avec
communiquer là,
plaisir, ouais.
c'est une recherche euh, du Allen Institute pour l'intelligence artificielle.
D'accord, envoie le lien, on a perdu le
Ce sera
temps.
plus simple.
Super, merci.
Chloé, merci beaucoup pour ça. On a tout apprécié ça. Pas parce que j'étais d'accord à propos de l'émotion, mais pour l'ensemble. Et j'espère que vous allez assister de temps à autre si ce créneau-là est disponible, parce que ça va vous intéresser. Et
Oui,
sinon, on a fait
j'essaye.
des vidéos pour toutes les...
Ah, c'est super, parce que j'ai voulu assister à certaines et j'étais pas disponible. J'ai assisté à une d'ailleurs, je crois, que j'étais là, mais au début, mais j'ai pas pu rester en entier. Et donc, oui, avec plaisir, parce que il y a plein de sujets intéressants qui étaient abordés, dont certains dans les questions, et j'aimerais bien voir les présentations. Oui. Je veux bien.
Merci et vive la transparence.
Merci.
Oui.
Au revoir. Merci beaucoup.
Merci beaucoup.